This question says to determine the mean, mu. Determine the mean, mu. How to determine the mean when you have a table like this? Assistant is in week 10, page 9 to 10. So let's check out what the weekly notes have to say with regards to the mean. So here is an example of the discrete probability distribution. Here we have the examples we did. You have example 10.4. Here you have the, the symbolism we talked about. And here is what we are looking for, how to find the mean, the variance, and the standard deviation of a probability distribution. You can measure the central tendency of a probability distribution with its mean and measure the variability with its variance and standard deviation. The mean of the population mean mu. Each value of x is multiplied by its corresponding probability value and the products are added. The mean is also called the expected value, written as E of x. So mu is equal to the sum of x times p of x, or E of x is equal to the sum of xp. Steps: separately multiply each random variable x to its corresponding probability value. Sum the products again obtained in step 1. Variance of population, sigma squared. Sigma squared is also written as variance. There are two formulas, method 1 and method 2. Here's the instructions for method 1. This can bring us reminders of variance in numerical analysis. There are two methods. You have method 1, and the same thing is occurring for probabilities, and you have method 2, and the standard deviation is the square root of the variance, and you have an example showing you how to find the mean and the variance. As you can see, the mean, there's the probability distribution in a column form. Each value is multiplied to its corresponding value and the value is summed. So that's basically how you have to find the mean. Now, once we have sigma involved, then we have to think of a table. And once you think of a table and in front of a computer, just think of Excel. Simple as that. So I repeat, once you see sigma, here is sigma in the mean formula, think of a table. And once you think of a table and you are in front of a computer, think of Excel. Okay. Don't think of taking a pencil and a ruler and drawing a table. No. In front of a computer, because when you go in the workplace, how many employees do you see with a pencil and a ruler in front of a desk, drawing a table on a sheet of paper? How often does that happen in the capital city, Roseau, in the different workplaces? That's why I'm saying now, this approach to do this course, I think, has a lot of advantages because it's giving you the exposure to the tools you'll be using, okay, when you go out there. Okay, from last semester to this semester, trust me, a lot of improvement happened to this course from the past years. It was being done on the whiteboard. First started with chalkboard, a lot of chalk, but then we upgraded to whiteboard. I think this is an upgrade. Okay. You are not going to be taking a pencil, a pen, or a ruler and a sheet of paper and drawing a table. How many employees do you see doing that in the workplace? So little, none probably. So we have to calculate the mean. Here is the formula. Okay, and also this formula is in the a list of formulas. Okay. It's in the list of formulas. Okay, here's a list of formulas. Remember, we said we're going to use all the formulas in this list because I did not construct the formulas and then the module was constructed, and then all the formulas that will be used was made into a list. So that formula came from the weekly notes. So it is guaranteed we are going to use all the formulas in that list. Okay, and we on mean for probability distribution. Okay, so let the list come up, and here it is. We have to do all what is to the right of sigma first. That's why we need a table. We have to do all what is to the right of sigma first. Come on, come on. So here we have the problem. Here we have the formula. Here we have our calculator, Excel. So we create a table created for us already. The first column, we put the X values. So X is a general letter representing whatever you define it to be, and X here is A. So if you want, I can even put the capital A there. And its corresponding probabilities. This is a heading, so it can be centralized. Okay. Everything can be centralized, but the heading can be placed in bold. And the font can be increased. Now the A values are 7, 11, okay, 7, 11, 7, 11, 7, 11, 15, 19, and 23. So these are our X values. And our probability values are 0.424, 0.25, 0.036, 0.17, and 0.12. Okay. And we want to do X times P of X. That's what we want. That's what we want to do. We want to do an XP of X, or we want to do an XP. That reminds us of FX, isn't that so? But here no, P of A, sorry. A we're dealing with the formula of X, but it's A. So we want to do an A okay, so what I can do, I can just drag this. I'll get the font one time and I'll get something I need, right? So I want to do one and go up there. We want to do an A P of A. APA. Okay, and put the multiplication sign between it. We want to do an A times P of A. Okay. So the first A times P of A, we type equal. The first A is in A2. Or we can just click on A2 times, click on P of A, it's P of A, enter. Okay. And we can just double click on the friendly green box and we can just go to auto sum. And once you find the total thereof, that will give us the value of mu. Copy, Control C, minimize. Control V. All right. And therefore, mu as a population mean is a parameter. So just to reiterate the fact that this is a parameter, therefore the population parameter, remember population parameter and sample statistics. Okay, the word statistics is just like the word May. Spells the same and it has two different meanings. The month of May, and I may do that. Or can I go there? Or you have a can for to put some sardines. Now, statistics is just like that. Statistics is a process, but you have sample statistics. The word statistics has two meanings, at least two meanings. Of a process and has numbers calculated from a sample. One of the main categories, sample statistics. But this is a population parameter. Mu. Okay. Mu is equal to 12.248.